So how do you make an AI smarter? It sounds a little backward, but one of the best ways is to figure out all the ways to break it. Today, we're diving into something called TextAttack, a framework that shows how attacking AI is actually the secret to making it stronger, tougher, and, well, a whole lot more trustworthy.
All right, so here's our game plan. We're going to start by seeing just how easy it is to fool a really sophisticated AI. Then we'll get into the chaos this created for researchers. After that, we'll look at the awesome solution that brought some order to it all. And finally, we'll talk about why this is so critical for a future where we can actually rely on AI. So first up, how exactly do you fool an AI? Let's take a look at a pretty powerful model, one that's designed to understand human language, or at least that's what it looks like on the surface. Okay, so we give it a simple movie review. Perfect performance by the actor. And boom, the AI totally gets it. It comes back 99% sure that the sentiment is positive. You'd think, wow, this thing really understands English. But what happens if we just make one tiny change? Get ready for this. We swap out the word perfect for a super close synonym, spotless. Now, to you and me, the meaning is exactly the same, right? But the AI, it has a complete meltdown. It flips entirely, now saying with 100% confidence that the sentence is negative. One single word just caused a total failure. This little trick is called an adversarial attack. And what it shows us is a really shocking weakness in the kinds of AI systems we're starting to depend on for, everything from customer service to filtering content online. And this wasn't just some clever party trick either. It was actually a symptom of a huge, chaotic problem that was tearing through the entire field of AI research. Just imagine a field full of brilliant scientists all trying to build a castle. But every single one of them is using different blueprints, different tools, and they're all speaking a different language. That's basically what AI security research was like before 2020. It was a complete mess, which made it impossible to compare one attack method to another or even build on what other people had discovered. And as the researchers behind TextAttack put it, these barriers were seriously holding back progress. All this chaos was stopping the whole field from moving forward and building the kind of robust, reliable AI that we all actually need. So to solve this problem, a team of researchers built a universal toolkit for attacking AI. You could think of it like a recipe book for finding an AI's weaknesses, and they called it TextAttack. Now, the key here is to think of TextAttack not as a single attack, but more like a fully stocked kitchen. It's this brilliant framework that breaks down every possible attack into 4 simple mix-and-match parts, letting you cook up any kind of attack you can imagine.
And these are the 4 key ingredients in every recipe. First, you've got the goal function. That's your objective, like trying to flip a positive review to a negative one. Then there are constraints, which are basically the rules of the game, like making sure the new sentence is still grammatically correct. The transformation is the actual change you make, like swapping a word. And finally, the search method is your strategy for finding the best word to swap. Every single attack out there is just a different mix of these 4 simple ideas.
And this is where it all snaps into place. This table shows how these famous attacks are really just different recipes. You can see TextFooler and AllsOnTote both swap synonyms, but they use different search strategies to do it. Deep Word Bug is even sneakier. It makes tiny edits to individual characters. This standardized framework was a total game changer, because for the first time, researchers could do fair, apples-to-apples comparisons of different attacks. So, having a systematic way to break models is powerful. But here's the real twist. The ultimate goal of TextAttack isn't just about destruction. The true mission is to turn these attacks into a training tool. By systematically finding all of a model's blind spots, we can actually use that information to teach it to be smarter. And this is done with 2 really powerful techniques: data augmentation and adversarial training. First up, data augmentation. With TextAttack, you can automatically generate thousands of slightly different but still correct sentences to beef up your training set. And this chart here shows you just how well that works. It gives the model's baseline accuracy a really nice boost. And this is where the real magic is. Adversarial training. On the left, a standard model just gets absolutely wrecked by the TextFooler attack. It fails on more than 97% of the examples. But check out the model on the right. This one was trained on the very attacks that TextAttack generated, and it's now over 13 times more robust. It's like it learned from its own mistakes. So, what does this all mean for the future? How does breaking AI help us build a world where we can actually trust it? The impact here is huge. TextAttack creates a level playing field for comparing attacks, it speeds up the creation of new defenses, and maybe most importantly, it makes this whole field accessible to everyone. Now, anybody with just a few lines of code can help make AI stronger and more reliable.
So here's the big takeaway, and it's one of my favorite kinds of ideas. It's totally counterintuitive. Our best defense is a great offense. By giving the whole community a toolkit to find and expose flaws, we all work together to build a much stronger defense.
You know, this isn't just some abstract academic project. This is laying the foundation for AI we can actually depend on, in our self-driving cars, in our medical diagnoses, and in a million other ways that are going to shape our future. It's a great reminder that to build something truly intelligent, we first have to understand every single one of its weaknesses. The stronger our attacks get, the safer it becomes for all of us.